All right, so here's question number 70. Let g be that function. At what value of x does g have an absolute maximum? So how do I find an absolute maximum? So I'm going to do a table of values. And the first two numbers I check are -2 and 2. Those are the ends. Then, after I do that, I'm going to take the derivative and make it equal to 0. I also want to see if there's a value that makes the derivative undefined, which there won't be because it's a polynomial. And I use that number too. This. All right. So I need you to plug in -2 into g. If you did that, you get an answer of 112. If I plug in +2 in, I get an answer of -16 just by plugging in and doing the work. Take the derivative. That's 12x cubed minus 24x squared. Make it equal to 0. We're going to factor out 12x squared. That gives me x, subtract 2. So the two answers are 0 and 2. So we already have 2, that's here, at -16. We'll add 0 to the list. 0 gives me the answer 0. And so the question for number 70 is, at what x value do you have maximum? So that answer is -2, because it gives me the greatest value. Number 71, let g be that function. How many extrema does that one have? Both maximums and minimums. So how do I do that? So I'm writing down the function to find how many extrema, how many maximums and how many minimums. You take the derivative and make it equal to 0. So the derivative is 4x cubed plus 12x squared. We're going to make it equal to 0. We're going to factor out 2x squared. That leaves me with 2x. I'm going to factor out 4x squared. Let's get the largest, greatest common factor. That gives me x plus 3. So 4x squared gives me the answer 0, and x plus 3 gives me the answer -3. So I have 0 and -3. Let's put -3 first, then 0. Here's your first derivative number line. And then test it. So if I plug in a number smaller than -3, so -4, that gives me a negative answer times a positive answer. If I plug in a number between -3 and 0, like -2, that gives me a positive answer times a positive answer. And if I plug in an answer greater than 0, like 1, that gives me a positive times a positive, which is positive. All right, so we only have an extreme value if the signs change. So there's only one spot where the sign changes, so we only have one extreme value. So the answer to 71 is only at -3. So let's check the answer choices here. So for 71, the answer is B. There's only one choice. Only one extreme value. All right, number 72. This function's defined this way. Where is there a relative maximum? So to find the relative maximum, I want to know when the function changes from increasing to decreasing. So I'm going to first take the derivative, and then I'm going to make it equal to 0, and I'm going to draw a number line. So I want you to write it down, take the derivative, make it equal to 0, factor out a 3x. So the two answers are 0 and 2. Those are called critical numbers for the first derivative. Then we're going to plug in a number. So plug in any negative number, and it's a negative times a negative. Plug in +1, and it's a positive times a negative. Plug in a number greater than 2, and it's a positive times a positive. All right, so where's the maximum? So at 0, it changes from positive to negative. That's a maximum. So at x equals 0, we have a maximum. The other one's a minimum. So the answer to 72 is B when x is 0. 73. In 73, you're given the graphs of derivatives f, g, and h. which of the functions have a relative maximum there? So if I'm looking at derivatives, which one crosses the x-axis? So not the third one. The middle one here, it crosses, but it goes negative to positive. That's a minimum. Here, it crosses from positive to negative. Only this one has a maximum because it crosses from positive to negative. That creates a maximum. So only F. So the answer for 73 is A. 74. In 74, you're given the derivative, and which of the following has following which extreme values? So I need to draw a number line, first of all. So I'm going to do that. So for 74, I'm going to draw a number line for the derivative. And the zeros of the derivative are 2, 3, and 4. So I'm going to do that. 2, 3, and 4. Now, what makes this quicker is to understand the end behavior of the derivative. If I understand the power term, x times x squared times x cubed. If I multiply it out, add the exponents, it's x to the 6th. That's the power term. And if that's true, if that's the power term, then both ends go up. And then I just see what the multiplicity is to know if it crosses or not. So at 2, it's odd. And at 4, it's odd, because it has an odd exponent. So wherever it's odd, it's going to change signs. 3 has an even multiplicity, so the sign stays the same. So at 2, we have a maximum, and at 4, we have a minimum. So now let's look to see which ones could match that. So at 2, there's a maximum, and at 4, there's a minimum. So the only one I see that's right is 1, that at 2, there's a maximum. So the answer to number 74 is A. 75, let f be that function. I'm going to write it down. So it's f at x equals sine x times e to the negative x. And it's from the interval negative pi over 2 to positive pi over 2. And then it says, where is that function increasing? So I need to take the derivative and see where the derivative is positive. So can you take the derivative here using the product rule? So the product rule is the first times the derivative of the second, and it has a hook of -1, plus the second times the derivative of the first. There we go. Make it equal to 0. We're going to factor an e to the negative x in front. That leaves me with negative sine x plus cosine x. Now, e to the negative x can never be 0. It's always a positive value. So only negative sine x plus cosine x will give me any critical numbers in terms of what I'm looking for. So if I add sine x, at what angle does sine and cosine equal each other? Between negative pi over 2 and pi over 2. So that happens at a 45-degree angle, and that's at pi over 4. That's the only angle in my restriction where cosine equals sine. So I'm going to draw a number line from negative pi over 2 to positive pi over 2. And pi over 4, the derivative is 0. There's a possibility of an extreme value at pi over 4. So I need to plug in a number here. So the easiest number to plug in here is 0. So if I plug in 0, this will always be positive. The angle 0 gives me the answer 0 and positive 1. So if I put it together, the answer is actually positive. And then if I pick an angle here, maybe you could pick like pi over 3. Both of these have a positive value, but sine is a bigger. It's root 3 over 2, which is bigger than a half. So this will actually give me a negative answer. So at pi over 4, there's a maximum. But the question really is, here we go. The question really is, where is it increasing, right? So where is it positive? So it's positive from negative pi over 2 to pi over 4. The answer is D, because the derivative is positive in that interval. 76. Let f be that function And I'm just going to write x subtract a times x plus a, where a is a positive constant. And it says, which of the following statements is true? And we're looking at increasing and decreasing. In particular, where is it decreasing and why? So if I look at that and make it equal to 0, a is a constant. So when x equals a or negative a, this will be 0. So if x was a take away a is 0. If it was negative a plus a is 0. That will give me the answer 0. So I'm going to draw a number line, and I'm going to label negative a and positive a on that number line. Now, if I multiplied this out, the power term would be x squared. That means both the left and the right end are increasing. In the middle, we have an odd multiplicity, so the sign changes. So between negative a and positive a, the function is decreasing. So between negative a and positive a, the derivative is less than 0. It's decreasing. The answer is A. All right, we're almost done. 77 takes a calculator. Let's do it. So for 77, it says take that equation, and it's already the derivative. And where is it increasing? So all I want to know is where is it above the axes between 0 and pi. So take out your calculator, and we're going to do it. So take out your calculator. We're going to graph it. So go to your graph. If you have something there already, delete it. And then type in sine x plus. Now, if you type in x cosine x, you have to go x times cosine x. So you can't just go x cosine x. You need to go times cosine. So let me show you that. If you just type in x cosine x, it won't give you, it won't know how to graph it. So you got to go x times cosine x. See that little dot there in between? Then it will graph it, and it's going from 0 to pi. So I'm going to change the window, and it's going to go from 0 to pi. And again, what I'm looking for is right there. Like, where does it cross? See right there, where does it cross? So go menu and 0. So analyze and 0. And then think, where does it cross the... It got stuck. Let's try it again. Mine didn't want to go across. So analyze 0. Let's see if it goes across. There it is. Sometimes it has little bugs. So there's the low. Oh, in the lower bound. Oh, let's try it again. One more time. I want to analyze it. I want to find the 0. So to the left of it. There it is. I don't know why it's acting up on me. And then highlight over. Finally, it's right there. So it's 2.02. It's a maximum right there. So 2.028, and it's a maximum. So they have 2.029. So where is it increasing? Like, where is it above? From 0 to 2.029, if you rounded it, it's above and then it's below. So it's increasing from 0 to 2. The answer is B. Number 78, we're going to use our calculator again. And again, it asks for on what intervals is the graph both increasing and concave down. So let's type in, first of all, just type in the first one, the derivative. We can just look off the derivative. So erase what you just have. And type that in. I'll give you a moment. I'm typing it in too. Make sure I type it in correctly. 3 ln 2 plus cosine 2x subtract x. I'm going to tell you what I'm looking for. So again, we're looking for increasing and concave down. Increasing and concave down. Oh, I got to make sure I have my interval. And that's from -2 to 2. So menu, window, from -2 to +2. All right, so where is it increasing and concave down? So it's increasing when it's above, and it's concave down. So past here, it is decreasing. So we don't want that. Increasing is above. Concave down means the derivative is decreasing. So I want to find the turning points. So let me take this equation and move it so I have room to actually analyze the graph. So I'm going to go menu and find the turning point so I can know exactly when it changes direction. So I'm going to find the minimum there to begin with. So if I go to the left and to the right, so first of all, it's above and decreasing. That means increasing and concave down. So from -2 to -1.485, that's 1. Now I want to find the next turning point. So I go menu again, analyze. The next one's a maximum. So that's 3. And so again, I want to find it. So to the left of it and then to the right of it. So at -0.250, it starts decreasing again all the way to the x-intercept. Because once it's below, it's no longer increasing. So the x-intercept, the 0, there it is. So then you find that. So it goes from -2 to -1.45, whatever. From -0.25 all the way to 1.085. So that's the intervals. So I'm looking for above and decreasing. Above and decreasing. Once it's below, it's then not what I'm looking for. So then which one matches that? So the correct answer for the right interval is A. So -2 to here, it's above and decreasing, and -0.25 to that. Both of those intervals, it's above and decreasing. All right, here's the last one, number 79. You're given a table of values, and you're given the derivative and second derivative. It says at what values of x does the graph have a point of inflection? We have a point of inflection when it changes signs. So if I look here to the left and to the right, the second derivative goes from positive to negative. So even though the derivative's undefined, it still creates a point of inflection. Here, same thing. When I look at 8, it goes from negative to positive. So at 8, the derivative is 0 or undefined. Both of that gives a point of inflection. Look at the last one. The sign doesn't change. So when I look at that, where are the 2 points of inflection? And the answer is 5, and the answer is 8. That's because the sign changes for the second derivative around those two numbers. And you're done. Mr. G Math over and out until next time. And I'm super proud of you that you did this really long assignment with me.